So we first start off with a little tiny gameplay demonstration, and then right after that we'll move to some features, and we'll go back to looking at gameplay. Okay, so the first thing you notice here is this is our player character up here. What you have is an orb, and rotating around it is a thruster. And so this thruster rotates about once every second or so. And whenever this thruster is in the position that you want to move, you press spacebar, and that'll thrust you in that direction. So within about a second, we've offered our users 360 degrees of movement freedom with only a single button. And we also have some users on their input device will have a default state as well as their on and off state. And for these users, we allow one extra button functionality which slows down the player, the orb, in order to gain a little bit more control of the system. We've also implemented, as you can see here, some collision detection. It's actually pretty advanced. We built it out of lines and polygons, so it's almost pixel perfect in its implementation. You see the health bar down here, which you lose about 50% health every time you run into a wall. And every time you pick up a star, the goal of this game is to pick up every star on the level to regain some health. So we'll see once he grabs this last star here, we go to the next level. We designed these levels in Maya using curves. And so if you ever want to design a new level for this game, you can do it really easily in Maya. You just create a CV curve, export it to a file, and we can parse it in as any Maya ASCII file. We can parse in the curve and read it as one of our levels. So if you want to switch over to PowerPoint real quick, we can go over a couple of our slides. Or nothing is impossible. So first, when we were trying to come up with some ideas, we thought we might do a rhythm game, tic-tac-toe, card games, and then we finally came to our orb game because it really offered us, a sense of fast-paced action, which we couldn't really kind of surprised us for a binary input game because we didn't think that might be possible. So what is Orb? Orb is a fast-paced arcade game designed from the ground up with movement-impaired accessibility in mind. So like I said, the orb has a thruster that constantly rotates and facilitates 360-degree movement. The input is spacebar. Of course, this will be adapted for users can only blink or shrug their shoulders or what have you. But two inputs for now: spacebar and C. One fires the thruster, one slows down the orb, and the orb will bounce back from any ball that it hits. So like I said, you can import external map files easily created in Maya. And if you don't have Maya, it's just a list of text numerical values for the points and the things, so you can create those by hand really easily. And we also implemented some pretty advanced momentum, acceleration physics, as well as collision detection. You guys want to talk about that for a little bit?
Yeah. Okay, so basically, whenever in the game class, there's a while loop that will constantly call an update on the orb. And the update basically will say, okay, the button is pressed, they'll add a little bit of acceleration to the speed variable, and basically the speed variable will always, it will never fall to zero. It will always be kept on adding to whenever the thrust is added. And I think that's basically it. And of course, there's also maximum speed, just so that it wouldn't go way too fast.
And also the collision and the bouncing feature is based on, basically when the ball hits into the wall, it hit by a certain angle, and we want to make sure that when the ball hits to that angle hit to the wall by that angle, and it come out exactly that angle, just like the light. When you shine the light into the mirror, it's supposed to come out with exactly angle. So actually we constantly change the coordinate
So all these technologies we design ourselves. We didn't use any game engines or anything. We just use the basic graphic APIs of Java that most of us learned as we learned. We also included, most of our elements are high contrast. For accessibility, we have a really obvious health bar. All our elements, color schemes go, they're very distinct. And so the most important part about this game is the control system, which are for users that don't have, I'm sorry. The controls are also for users who have default states. So we add that extra sub button, and those who don't, who just have a single, on, off, blink or not blink sort of state. So one of the big challenges is balancing, gameplay challenge difficulty with accessibility, and I think we did it pretty well. You'll notice that if you start the game, it's really easy to pick up, but it's really hard to master. And I think that helped make us very successful. So a couple of feature developments that we'd like to see added, because it's open source. Multiple players. We made it pretty portable. All the elements are very distinct, so you can add multiple players really easily, just by adding extra objects, and what have you. More different levels of challenge, maybe some more options with speeds and what have you. Built-in map editors, it's already really easy to make your own maps, but if you don't have mine, it might be a little bit harder to do it manually, so you can make one of those right in there. And more adjusting the timing controls. So we'd like to thank these people up here for helping us out. And we're going to demonstrate a little bit more of the game here.
Get to the end.
Okay, I'll show you the end of the game here. We'll get past a couple levels. So I don't like using the slow button. So you can play it either with the slow button or without it. It works just as well either way.
So we're very forgiving in hitting the walls and giving the player multiple chances. Because people with limited mobility, there's no way to tell how quickly they. Oh, it seems to be out of time. But that's our game, or.
All right, thanks very much.